Good evening, you guys. My name is Yaslin Delgado. I chose my presentation to be on the chemical traffic light experiment. I will start by demonstrating you a video of the actual experiment being performed. Okay. Here we go. So it's obviously called the chemical traffic light experiment because it goes from red to yellow to green. So in order to perform this experiment, the materials you would need would be 3 grams of dextrose, also known as glucose, 5 grams of sodium hydroxide pellets, between 5 to 10 milliliters of indigo carmine indicator solution, 250 milliliters distilled water, and a round bottom flask of 500 milliliters, a stopper, and a stirring rod. Safety precautions you should know is that the sodium hydroxide is a corrosive chemical. When shaking, use caution, and this is why you also should always wear your personal protective equipment or your PPE, like your apron, gloves, and goggles. Make sure the stopper is on tight when you put it into the flask so nothing will spill. And the experiment preparation or the instructions are: first, you put 250 milliliters of distilled water in a beaker. You add 3 grams of dextrose and stir it until it dissolves. After that, you add 5 grams of sodium hydroxide pellets into the same beaker and use a stirring rod to break apart the pellets so that they will dissolve quicker. Pour the contents of the beaker into the glass flask and add between 5 to 10 milliliters of the indigo carmine indicator. There should be enough of the solution so that it will be able to turn a yellow color. After you add the indigo carmine indicator, put the stopper in the flask and let it sit for 10 minutes or else it will not work. So you have to wait patiently for 10 minutes. After the 10 minutes, you can shake it once or twice and it should turn a red color. Then you shake it again and it should turn a green color. Then if you let it sit for a few minutes, it should turn back to the yellow color. So the chemistry part about this is mainly on the indigo carmine. This is the formula for indigo carmine right here. The indigo carmine does undergo a reversible reaction, just in case you didn't know that. And there are 3 forms of indigo carmine. The first form is the oxidized form of indigo carmine, which is green in an alkaline solution. The indicator reduces in a glucose alkaline solution. The second form is the intermediate form of indigo carmine, which is red. And lastly is the fully reduced form of the indicator, which is the yellow part of the solution. So when the flask is shaken, oxygen from the air dissolves in the solution and oxidizes indigo carmine. Solution becomes red if a small amount of oxygen is dissolved. So if you moderately shake it, it'll become red. And if you shake it intensively, it'll become green. That means it's oxidized. So waste disposal instructions. You can throw it down the drain, but it is recommended to neutralize the sodium hydroxide first by adding an appropriate amount of acid. In this case, the 5 grams of hydroxide is neutralized by about 17 milliliters of 20% sulfuric acid. After you finish a demonstration, the indicator will act as an effective indicator once it turns blue. So once it turns blue, you can flush it down the sink. Once it turns blue, it means it's neutral. And here's my works cited. It's the websites I visited for information. If you have any questions, please comment. Thank you for watching.